Wait, now we still okay. Record. So I share the entire of my screen. Can you see this one? Chapter 1, introduction.
Yes,
Hello.
yes,
Yes, doktor.
can.
Boleh,
Nampak tak tu?
doktor, boleh. Oh.
Okay, can you see it very clear or not?
Ya,
Clear tu.
doktor.
Clear, clear.
Clear.
Clear, doktor.
Okay. So here we call it a chapter 1 introduction. So of course our subject is engineering survey. So under the UITM code is CEG 452 under Bachelor of Civil Engineering with infrastructure. Right. For this chapter 1, the learning outcome is the lecture focus on introduction to broad aspect of surveying works and its application to civil engineering. And after this lecture, the student should be able to, number one, able to understand the theory and practice of various surveying work applicable to civil engineering, able to understand the type of general handling of equipment in surveying, identification of error and error elimination. I think you still remember that identification of error and error eliminations when we have, remember that rise and fall in leveling? You still remember we call it HOC and we do arithmetical checking, right? So this
Yes.
what the meaning of this one? Identification of error and error eliminations. And then for example that able to understand this one, able to understand the theory and practice of various surveying work applicable to civil engineering. We will look up that you understand the theory, for example that how to do we call levelings, how we call it the effect of your survey and then you are doing a practice on site and then you know how this theory and practical is applicable. Mean that's what kind of project is he wondering that should related for. For example, that leveling is we call it maybe to handle we call it you want to do the earthwork for canal, you want to do the earthwork for the highway, for roads, bridge project and so on. And second one is able to understand the type and general handling of equipment surveying. I think you know already how to do. We call it general handling. How you want to conduct. We call it a survey using a levelings. How you want to carry out. We call it your survey equipments. How you want to carry out. We call it your tripods. What is the safety behind this, and what is the fundamental if using this one. What we want to search for. What the value want to get it. Okay. So this we call it learning outcome. So actually, definition for surveying is defined as the art of measuring distance. It's arts. It's sometimes people not don't say science. In science we have arts. As the art of measuring distance, you know that measuring distance, what kind of distance for you from your equipments to your station B, from one point A to one point B to one point C. You want to measure the distance and angles and then positions on or near the surface of Earth. Position means that you know the we call it UITM Pulau Pinang. Where is the position? The position means that maybe you measure it by coordinates. So coordinates maybe using we call it a GPS, for example. Okay, so that means we call it positions. And using distance and angle also you know the position because everything's on Earth the position is different. That's why we must measure the distance, measure the angle. We just want to know the positions. But GPS don't have a capability of distance and angles. They're using something like you have, we call it a plot or paper graph. Then from that paper graph, you know the position. For example, like this graph paper. You know this one is station A, and you know this one is station B. So you can calculate distance from here to here. You calculate from distance here to here. So here normally we say Y. This one is X. Okay, X. Alright. So next, objective of surveying. Preparation. For example, preparation of maps, plan, sections. What kind of maps? We want a contour map because we want to know the cut and plan, the cut and fills. What is plans? We need a building plan because building plan normally on site, on earth. So we want to know the plans and the site must be in, we call it, good order. We cannot, we call it, put our plan on maps not in the same, not, we call it, the scale is not the same, the projection is not the same. Okay, sometimes we need sections. For example, that you have contour, so you need a section like this because you know what you want to know the topography and you want to understand about the volume of this section. Okay, to the determination of relative position of natural and artificial measure on a surface so that correctly represented on maps, plan or section. So everything on grounds, we want to know the plans, the maps and the sections for that place because we want to know the quantity, we want to know the price, we want to know the neighbor, the adjacents, who is our neighbor, what is the effect, we call it, if we build out housing schemes in the surrounding area where we have a very polluted mills or very polluted factory. Okay, so that's why we want to know. Okay, next is setting out. It's the process to transfer information from plan to the ground using surveying equipment. This setting out actually we will understand if we are doing our lab for 40 weeks because last week we have setting out. For example, that you still remember that on your practical side, I want you to measure, we call it a grid system. You measure, we call it benchmark. And you measure that every single vertex or every single points of your grid systems to set up the contour, right? After you get the contour, on your grid system, we draw a plans, then we design the housing. We design a plan of maps. Normally a building, for example, sometimes it's very trigger, it's a very one, make it a challenge. I want the student to design a surau because a surau have a orientations going to Kaabah, and then they put it in their setting out of contour. What you already done in your field, that is setting out. So we plans the setting out, the surau, okay, design, and we are integrated with your maps or plan or contour. After you acquire that one, you calculate, you draw the contour. So we put up and then we rotate. On paper, we rotate to the Qiblah. Then we get the angle, and distance and positions. From this map, we are going back to your field. So you still remember your field in front of the Pusat Islam? We are doing a setting out of surau on your setting out of contour. That is how the beauty of our practical survey. Actually, this we call it CEG 452 is actually I'm designing the syllabus, and then the practical one I control based on the industry needs. That's why our student is very good. Unluckily, because we have PKP now, you cannot, we call it filling this setting out. This is normally, um, we call it a mismatch between academic industry. What I say that why the student is not really admired by, we call it employer. So one of that we doing survey works based on our academic only. We never ever see the final product. Okay, that is setting out. Is the process to transfer information from plant to the ground using survey instrument. Okay, last one, computation area and volumes. The execution of calculation for land area, earthwork volume are based on field measurement or measurement extracted from maps, plan and section. So, because sometimes we call it, we have this, we call it this type of what we call it topography, and then we cut it because we want to build up maybe housing here. Okay, so we cut. So we know the actual volume, and we know what is how much the cut. So that is computation area and volumes. So this is three main objective of surveying. Okay. So in survey actually in general we have surveying. We have two, geodetic survey and plane surveying. Alright. What is plane surveying? Look at for this one. The surface of the earth is considered to be a plane for all x and y dimension. So we assume earth's surface is flat. This is we call it plane surveying. And all z dimension is high are referred to mean sea level. This is what we are doing now. Plane surveying. In plane surveying, relatively small area are under considerations. So something that you want to do, we call it the housing scheme, our practical works, we call it plane surveying. But geodetic issue survey is more. For example, that we want to measure the curvature effect in Semenanjung, Malaysia, from Perlis, Arau, going to Tanjung Piai, Johor. So that is we call it geodetic survey. Because it's a joint. Joint mean that our earth is a joint. Mean that our earth is, we call it sphere. Right? So normally joint, if you are measure from United States of America going to Malaysia, you have the effect of joint. Okay? The surface of the earth is considered to be spherical for x and y dimension, and the z dimension height are also referred to mean sea level. The traditional geodetic surveying were very precise survey of great magnitude, national boundaries, control network, etc. National boundaries mean that in Malaysia we have, we call it in Sabah Sarawak, we have a neighbor Indonesia. So Sabah and Sarawak we have neighbor Kalimantan Utara, Kalimantan Selatan. So we using geodetic survey for our national boundary. Okay, control network mean that, for example, that you have the map of Malaysia, right? I think you still remember that this shape, for example, this sorry. You have, we call it Malaysia. Peninsula of Malaysia, something like this. It's good, something like this. So you know that this one is Bajaran Titi Wangsa. Bajaran Titi Wangsa, Bajaran Titi Wangsa. Okay. So at Bajaran Titi Wangsa, Japan have control points. They have a point along with Bajaran Titi Wangsa, Banjaran Titi Wangsa. Along with that, they we call it put up. We call it something like marker here to make sure it's a backbones our control network for Malaysia. So because they have this one in the Banjaran Titi Wangsa, they can measure. I think 2004 when we have tsunami. They believe peninsula of Malaysia shifted around 5 mm. So they're using this one, control network at Banjaran Titi Wangsa. Banjaran Titi Wangsa, Okay. Continue. Modern survey, data gathering, control and layout utilizing the GPS global positioning system based on geometric shape of the earth. So GPS, I think we call it a Waze, we call it Google Maps, all the one that one using GPS. So GPS is something like they're using the coordinate, so X and Y. So from this one, they go from one position to one position, going to one position, going to one position. So from that, they know that the distance. They know the distance. So they not measure the angle and distance. So there's something like mathematics. You know the distance, you know the distance, you know this distance, you know distance, and you know this angle. Okay, so that is how GPS working. And GPS is not measure. We call it angle and the distance. But because of they have this point and they have X and Y, so actually they can know about the angle and distance and all the measurement. In geodetic survey, large area of the Earth's surface are involved and the curvature of the Earth must be taken into account. The curvature because we know that our Earth is spherical. So we are on Earth. We're not inside the Earth. So we stay on the land, on the surface of Earth. So mean that we believe this one is a curvature. Even though nowadays it's a very popular theory, they call it flat Earth. But this one is not proven yet. Okay? According to science. Okay, branches of surveying mean that actually you are going to number 2 engineering survey, and then sometimes you also involved with topographical, sometimes you involved with cadastral, sometimes you involved with hydrology, sometimes you involved with photogrammetry, and so on and so on. So topography is produce a plan or maps. So what we try to do is we try to produce a plan or map of contour in front of Pusat Islam UITM Pulau Pinang. Okay, next. Engineering. Embrace all the survey work required before, during, and after engineering works. And if you know because you already understand the fundamental of surveying to make a contour, so you also know how to do, we call it to set up a survey for, we call it for drainage, for drain. You already know how to set up a survey for the road construction. Okay? Right. So what the meaning of type of survey? Cadastral. Normally cadastral is carried out by professional licensed surveyor. So you cannot do this cadastral. But if that project you involve, you also can examining. You also can request from the professional surveyor about the data. So actually cadastral is to produce plan if property boundaries for the legal purpose. For example that you want to set up at one piece of land or two pieces of lands about the housing scheme. You want to develop it. And after the project, you maybe had a profit around 10 millions. Okay? Alright. So, every housing that you set up must have a good boundaries. And these boundaries must set up by the professional surveyor, SR. Licensed surveyor. So, you must check about the angle and make sure all the angle for the boundaries properties or for the housing must be close travas. If not close, mean that something wrong about the cadastral survey, because the cadastral survey is legal to make sure this bearing and distance going to draw in your land grant, ataupun kita panggil geran tanah. Okay, so in your land grant you have the distance, you have the stations, and you have the angles. Okay, so number 4 is hydrology, hydrography, dealing with the mapping of large water body. For example, that you have a river. Before you build up a dam, you want to know the how much the river can supply to your dam. So you must measure section by sections the river from upstream going to downs to make sure you get the exact volume of water that can supply to your new dam. And more critical, if the river is the drought, mean that when you have no monsoon of rains, you drought, the river dry. So how much the water can be put in your or store in your dam. Okay, photogrammetry. You know that nowadays it's not popular about the photogrammetry. You know about drone. It's something like using the photogrammetry mapping, producing map or map using photograph techniques. And you know that nowadays we have video. We call it video. We put it in the platform of we call it drone. And last time in photogrammetry, when we have the video, we put in aeroplanes. But we have pro and con about pro photogrammetry and drone technology. But the main purpose of this type of survey is to get the data very hard, very, we call it short times, and but the pricing is very high using a photogrammetry or drone. So survey equipment to measure distance, and equipment to measure angles. Okay, D is we call it, I think you should ignore this one, is a chain survey. D is just history. So now using a measuring tape already. Last time, a chain is as a unit of measurement within the empirical system. The chain is defined as 22 yards or 66 feet of 4 rods. A chain is divided into 100 links. So this chain is along with that, the overall distance is 66 feet, and the links is 100 links. So one link you divided 66 divided by 100 links, so you can get maybe 0.06 feet per links. Okay, so that's my story. Now we're using fiberglass tape. I think you already use it. Yes, we have fiberglass tape in our store, and tape are used for linear measurement. Survey tapes can be steel or plastic coated steel. And then this is the fiberglass or the plastic coated steel or steel. That is all the equipment that we want to make sure that our measuring tape is not expand during the measurement. And of course, we have offset tape. That's a small tape that we're using to build up the house. Is general, we call it layouts. So we also have offset tape. And then we are using prismatic compass. So prismatic compass is used to determine the nose direction and bearing. Why you need nose direction? Because we want to know the bearing. Okay. So prismatic compass, you cannot get the horizontal distance. You just measure the horizontal distance, the angle. And of course, you already have a theodolite. You use it. I already explained to you the component of theodolite. Okay. This one is quite old one. This veneer one is very hard. Nowadays we have a modern one. And this one is leveling. This one is leveling. This one is a theodolite. Okay, now we have level. The level and rod or staff, rod or staff are used to measure different in elevation. You already use it. And this one, still remember that I already told you about electronic distance measurement, EDM. And EDM we put on theodolite. Nowadays, they integrate theodolite and EDMs. They come up with new innovative measuring distance. We call it total stations. So, electronic distance measurements, they have two types. How they want to measure the distance. Number one, they're using a laser. Number two, they use a radio frequency. A radio frequency, either short wave or medium wave. Okay, so this is the we call it innovations. It's something like revolutions from tape using electronic distance measurement, and lastly we have total station. So there is a total station shape, something like tenolite, but last time we call it tenolite, we have EDM. So now they change it to the total station, and this total station here they build a laser that they can focus to the distance. Maybe here they put the prism. Okay. Now this is modern one, global positioning system. GPS receiver capture data from several satellites to determine position coordinate, north, earth, and elevation of the civilization. We will learn more about the GPS after this. Okay, this is a target prism. So target prism normally we are using with this one, a total station. Why? To make sure that if you have, we call it this laser, this is the prism. The prism will give you a reflect back about your laser, so they can calculate about the distance automatically. For example, that this laser going up and then it's going back to the auto station. Okay. Okay, we have extra. We call it normally we have a ring impulse. We have packs, we have tripod, we have plumb bob. Plumb bob already you know, a tripod you know, pack you have one, but your pack is not square, your pack is rounded. So hanging pole actually is using in, we call it chain survey. Okay, or sometimes we use in measuring tape. This one because we want to know the direction of the change direction, which direction we should go. So we are going to mark it with a hanging pole. For example, that from one point A to point B, maybe it's 20 meter. So we put because of 20 meter, we put every 5 meter. We put a hanging pole from station A to station B because we want to pull up a tape. So we follow the hanging pole. So actually hanging pole is the initial marker on ground. Right? Part 2, principle and type of frameworks, identification of error and error elimination. This lecture focus on type of frameworks in surveying and its application to civil engineering. At the end of this lecture, students should be able to differentiate type of error and how to minimize in surveying, understand to achieve high accuracy survey. Thanks. Basic principle, type of framework. On any area of land to be measured, it's always be possible to choose 2 points to measure the distance between them. For example, station A and station B. So we take it as a baseline. Other point can be relocated relative to the AB line by taking 2 others measurement. Okay, for example, basic principle of surveying. Line ties. Okay, number 2 is offset. For example, that we already have a base point A and B. And suddenly we have another one point C. So we know B to C is maybe 2 meter, A to C maybe 5 meter, and A to B maybe 4 meter. Okay, so C is, we know the point of C based on distance from B and based on the distance from A. So we get C. Alright, so we call it line ties. Offset means that you have line AB. So for example, you have a tree here. So you offset here for the center of tree going to this line by 90 degree. So this one is 3. So this is the offset. For example, here we call it a point. For example, that's you have lamppost here, lamppost. So you offset from here to here. So maybe this one is 3 meter, this one is 2 meter. So must be 90 degree. So this one is a lamppost. So the offset is that line AB is a become main reference in the straight line. So there is difference between line ties and offset. But this is two basic principle of survey. We want to know the position of A, B, and C, and to the another, we call it objects. Okay, so we have a traverse from A to B, A to C. Okay, and then what we do, we connect here. So we get this one. And we know this angle, we know this angle, we know the distance, and we know the distance. So this one we call it intersection and resection. And this one is a traverse. Okay, what is error in surveying? We are doing a survey, yeah, we say that we are doing correct things, we call it, it's a very good readings, we don't have make error, we control the error. So actually, for Malaysia, this one is not really affected us. This one is very affected for the countries who have 4 seasons. For example, United Kingdoms, because their weather, varies of their weather is very high. For example, from negative to the 40 degrees Celsius. Of course, their equipment, when they use in different temperature, they also come up with the effect of air pressure, humidity, winds, and so on, and so on. So error means the difference between observed and true values. Actually, it should be in normal condition 2 meter. Because of we are very freeze or thaw in a snow, so maybe you measure the distance is not 1 meter or 2 meter, maybe going to 1.8, maybe going to 0.8 meter, or 2 meter is maybe is going to 1.9 meter. So because this one is natural error, for example, temperature, air pressure, humidity, and winds. Okay, and source of instruments. Sometimes when you have change we don't have anymore. Now for example that your tape. So when your tape using in the Mecca, maybe the 42 degrees Celsius. Okay, the reading is different if you compare it when you in snow in Canada using same measuring tape, but the distance is not the right one. So you must remember that the instruments, the natural or the personal can contribute to error in surveying, and you must be alert. Okay, personal, wrong reading 88 instead of 58, wrong writing, wrong calculation. I think this one I already told you sometime, because we get borrowings. Sometimes we call it employer, we call it late give you, we call it wages or your salary. Sometimes you have a problem with your family or something that in a university, you not really satisfied with the lecturer, or they call it with our technician or administrative, so you cannot aware and stay alert on the field. For example, your friends say in leveling for staff at point A 2.20, so you say that 2.02 meter. Okay, so you are wrong writing, wrong calculation. Normally, based on your awareness, based on your motivations, based on what you face on that day. Okay, so still remember error in surveying, you have a nature, you have instrumental, and you have personal error in surveying. Okay, three type of error: mistake, gross error, caused by human being or surveyor. Okay, mistake can happen at early stage, middle, or at the end of the survey. Sometimes we start the survey first, we have the error. Sometimes in the middle of survey, or sometime at the end of survey. So because you have a checking system, you know at early stage or in the middle time or at the end of survey, you make the mistake. If the mistake is acceptable, is okay. But if the mistake is too huge, and maybe your client not happy with your data, for example that they want first result data, first order, so you get third order. So what we do? We must do a resurvey, and of course is reduce the company profits that your boss don't like. Okay, still three type of error: mistakes, gross error. Anybody can do mistake, even though that the lecturer, the people in industry so long, sometimes they don't recall it alerts about the measurements. So sometimes they also make a mistake. So when you do a survey, you must encounter all the angle that affect your survey works. To overcome mistake, check readings, read more than one time, read by other person. This one already I told you on site. Check reading, make sure level. Baca dua kali, read more than one time. And if you want not really sure, first you read for twice, then call your friend and read twice and compare the results. Systematic error. Okay, we have this one is a source of error. Okay, now we have mistake, gross error, and now we have systematic error and random error. What the meaning of systematic error? Due to the instrument used not standard. For example, that's you do a survey from we call it Arau to Kuala Lumpur. For Arau, using the different instrument, using EDM, and we call it total station. In Kedah, using that total station. Again, in Perak, using the EDM and theodolite. And sometimes using, we call it from Perak to Kuala Lumpur, is GPS. And of course, GPS is not the same standard with that leveling instrument. So you must convert. You not convert it. So this mean is the systematic errors occurs. Consistent characteristics mean that all your equipments must use sets all the same. For example, that air pressure, we call it about your consistency, about north direction. You are consistent with all, we call it teams, from Perlis, from Kedah, Perak going to Kuala Lumpur, using a same and we call it a same projection, the same systems. So mean that you are consistent characteristic, so you try to reduce the error. Value of the error can be determined by applying corrections. Of course, some of error we can do the correction, but some we cannot do. And this one, normally the client unhappy, they want us to redo the survey works. And if your industry, this one is not common, but the boss don't like, and sometimes we have a miscommunications. to deliver this work. Okay, the last is random error. It's a caused by different capabilities of the instrument used and the surveyor. So using different tools and different equipment and different tools and different equipment have varies in the specifications. So they have the limitations. So when you do a survey with different instruments, that can cause also a random error. Okay? The remaining error after all mistake and systematic error eliminated are called random. Okay, this one is called random. And lastly, the error are small and cannot be eliminated. Sometimes random error is too small. Sometimes very small that sometimes we can eliminate. Sometimes normally we cannot be eliminated. So if we cannot be eliminated, so we must redo our survey works. Okay? So that is for your slide 29. Thank you for listening. We are going to slide number 2. Wait, nah. Hello? Are you there?
Yes, sir.
Oh, yeah, it's very good. So this one,
Betul.
yeah. Now we are going to linear measurement, chapter 2. I already told you about this chapter 2. We have 3 types. One is using a measuring tape. Can you see this measuring tape? Can you see this?
Yes.
Yes.
Okay, all right. So can you see this? Okay, all right. Next, number 1, direct, we call it method. Then we go to optical method and EDM method. So optical method, this is the optical method. This one, you still remember that? Study opticometry?
Yes.
Yes,
And,
betul.
and the third one is this one, electronic distance measurement, EDM. After EDM, they set up a new one. We call it
To station.
total station. That is, we call it our chapter 2. Okay. So learning outcome. At the end of this fieldwork, students should be able to, number 1,
Understand the concept.
understand the linear measurement used in the survey. And then number 2, different type of equipment used in linear measurement. And number 3, know the correct way to measure horizontal distance using measuring equipments. Okay, what the meaning of linear measurement? Linear measurement is determination of the distance between 2 points on the surface of the earth. Is one of the basic operation of surveying. Measurement of horizontal distance or measuring linear measurement is required in chain survey. Chain survey we already not do it now. In traverse surveying and other type of surveying. For example, there is leveling. We have the cadastral survey. We have a plan survey. Okay, all this one is using a linear measurement. So we have direct method. We're using a tape. Direct method. This one. Okay. Number 2, we have optical method. Optical method. There is. And number 3 is a EDM method, or we call total session. This one. Okay. Direct method. So using a tape or using a chain survey. So this one we don't have, we call it technology already. We're using this one. Okay, using a tape. So indirect method, the distance actually measured during field works using tape, change, and etc. This is the most commonly used method for linear measurement. Equipment for direct linear measurement, measuring tape, this one. So you have Rangi Road and you have Staff. Still remember Staff? This reading, still remember Staff?
Yes, yes, Doctor.
Yes, your Staff made it from aluminium. Made it from aluminium. Okay, so there is actually, we had a procedure when using a measuring tape. Learn proper taping procedure as demonstrated by the instructor or the lecturer. Number one, the tape is checked and examining the full length and defects. So when you take a tape, so please check. Either the tape is, we call it, is for example, the tape is 30 meter. So when you pull, you can see that the tape only have 20 meter. It's short 10 meter. So you don't use that tape. Okay? Or maybe the tapes is in good condition, but one of the screw of cover is peel off. One of the screw is, you can see that it should be 4 screw on the cover. So today you can see just 3 screw. So don't use that tape because it gives you the wrong distance. Okay, number 2, lay out the tape without twist. So when you measure from point A, point B, make sure your tape is not twist. It must be straight up, must be straight and flat. Send gentle shaker down the band to strengthen it. Or sometimes you give a signal to your friends to lowering your tape to make sure that from point A and point B normally it's not difference. It is different height in terms of vertical. So maybe point A and point B, the difference is 2 meter. Point A is higher slightly 2 meter. So how you want to straight it? So it's quite difficult because you must stand up and then pull the tape, and sometimes if the distance 10 meter, maybe you need 5 manpowers to strengthen it. Number 3, proper gripping and stance. Mean that if you measure point A, point B, point A you grip. The person at point A must be grips. And you must pull by the students or your friend at station B. Alright? Don't grip and stance. It will cause your tapes is breakout, putus, breakout. Use of plumb bob and arrow. Okay, when you want to use arrow, for example, there is a station A and B is 20 meter. It's very, very long for your measuring tape. Sometimes you must measure 2 times. So you put, we call it a arrow first from A to point B. Make sure that this one is straight, or we call it aligned with these 2 stations. Then you pull the tape, follow the arrow, follow your arrow. And use of lumbar mean that, for example, that you still remember that you have a station A and B. So station A is higher than B, is around 2 meter. So you want to make sure that you put the tapes, you stand your tapes, you're gripping your tape at station A, and then you pull your stands, we call it your tape, or you pull your tape to station B. So because of the distance is maybe 20 meter, you need 5 students. So at point B, you cannot measure because your tape hangs 2 meter on air. So how you want to know that your tape going to your pegs? So using the plumb bob. Alright? Proper care of tape. So normally after you use a tape, so you must keep it the tape nicely. When you must roll is very slowly and gently, and make sure that the tape when you roll and keep it is not twist. Okay, and you must have feel not keeping. The student normally they are measuring, they put it and we call it in their minds, then they're going back. So when we ask, what is the distance station A to station B? Sir, 1.2 meter. And then the friend said, no, it's not. It's 1.02 meter. Because you not properly jot down your field note keeping. Field note keeping, the students normally don't care because they feel that after they finish the works and then finish the data. No, actually you must keep your field note keeping or book recordings or bookings on field because we want to calculate. The student normally they don't understand. That's why the field note keeping is not easy task for me or for the new lecturer or me to ask them to keep up and do the calculations because the students say after work finish, so finish. No, it's not finished. We need the data to analyze. If you don't have a data, the client don't pay you even though you do all your works because from data we make it a plans, we make it, we call it a drawing, to make it we call it a setting out, to plan your works and so on. So the field data is a really important and you must keep it as you keep yourself safe. Calibration of pace. Using a 30 meter calibration course, pace the distance 3 times, relax and use your normal stride. Okay. So sometimes you have a measuring tape 30 meter. You don't know which one is right, which one is wrong. So normally you take a new tape that you bought. Then you pull it to 30 meter and then you take the old tape that you want to do a calibration. You pull the tape same and parallel with the new one and you see either the difference in 1 meter, 2 meter, 3 meter, 10 meter, 11 meter until 30 meter. Is it at the same marker or is a different marker? But we believe a new one. The old one normally give you wrong data because the tape when we pull it, sometimes it will be expanded, it will be strains a bit. Okay, so that is the number one about using 30 meter calibration. And you must not record the number of pace for 30 meter on the provided form. So you must, at every meter, you must write, is it the calibration and the old one is same or different? If same, yes, you can use. If different, for example, shortage 1 meter or you elongate 5 meter, so the tape you cannot do it, you cannot use it on your works, on your field works. Calculate the average number of pace for 30 meter for your own pace. Okay. And lastly, don't try to conform to someone else. Calculate the number of meter per pace. Okay. So that is the normal calculation that you must be aware. You must calculate. You must calculate every 1 meter to understand your previous tape, or we call it the old tape, is it still working or not if we compare it to the new one tape. Okay, number 3, traverse measurement with tape. From a 6 station traverse point on the field and moving around the traverse in a clockwise fashions, measure all side forward and backward, always measure horizontal distance. Always lead with 0 end of the tape so that the read end at the point you are measuring from. Chaining arrow should be used to mark off intermediate tape length. For example, there's a measurement, okay, and then this a traverse point. For example, that from point A to point B, point C, point D, point E, and going back to point A. A, B, C, D, E. So you have five, we call it a station that is traverse. You measure like this direction. Okay. And then when you measure point A and point B, In between you put arrow. B and C you put arrow. Because we want to make sure that the line is straight. This one all the arrow. Okay? The procedure. Again, for measuring tape, arrow should be always be placed. Okay, arrow should be always placed in the ground at 45 degrees so that the plumb bob may place directly over the mark point. Record total length in fieldwork to nearest millimeter. So when you record nearest millimeter, mm. Measure each line backward also. Sometimes you measure each line backward because you want to calculate. Calculate the discrepancy ratio. Show how precisely you made your measurement and express as fractions. Ini kalau kamu nak tengok calculation of diffraction ratio, adakah survey yang kita buat itu betul? So diffraction ratio is equal to forward distance minus backward distance divided by average distance. For example, that forward distance you can get 10 meter. You backward you get 9.8. So this one average distance 10.9.8. You divide it by 2. So you get this is the value of discrepancy ratio. Okay. So forward distance 10 minus 9.8. So you divide it based on 10 plus 9.8 divided by 2. Okay. Number 6. Determine acceptability of each ratio. Your ratio should be less than 1 over 2000 or rather the denominator of your fraction should be bigger than 2000. If calculated ratio is not acceptable, remeasure the line forward and backwards. Note it's recommended that ratio are checked up as you go in order to correct any order that may rise. If we call it your discrepancy ratio, it should be less than 1 over 2000. Or you can use this one. Denominator of fraction should be more than 2000. So using these two one. If the range is out from this one and this one, you must redo your survey work. Okay. Traverse measurement by piece. Measure the 6 side and 3 diagonal of your puzzle by using your piece. Divide the pacing among your group. Each person should not pace each line. For example, if you have 5 group members, each person should pace one of the 8 lines. Record data in field books as shown in example note from the following page. Okay. Ini this is we call it booking sheet for the horizontal distance measurement. So you write from station where to station where. So your forward distance, your back distance, your average, your discrepancy ratio using the formula. And again, it's a total station, 2 station, a number of pace, distance, and pace by who. Okay, sometimes if you're working with a group, so you must put a name number 1, put name number 2, your group member. Okay, why we buy pace by? Because if we are not get the discrepancy ratio is very good, so we check by the person who pace the works over here. Okay, tape standardizations. So mean that you have a tape, but sometimes tape also give you, we call it error. Okay, so tension or corrections. So this is the formula. Correction type. P minus PS summation of L divided AE. And for the second correction, you have the formula W squared summation of L the power of 3 divided by 24P squared. Temperature correction, different, we have the angle of L time by T minus TS. Slope correction, this one, P equal to A squared divided by 2L. Reduction to mean sea levels, we have LH divided by R. So if you not understand the formula, you follow this one, the notation. For example, P1, PS, this one, P1, PS, field and standard tension respectively. And if you not understands all this terminology here, please refer to the notations. Okay, but this is the table for source of error and correction for tape. And this one is called tape standardization table. All right. I think already we call it discuss with you about the opticals. We have horizontal distance. What is we call it horizontal angle. Okay, what is S? Okay, remember that horizontal distance equal to KS cos squared theta. And what is S? What is K equal to 100? What is cos? Is normal formula. Theta, this angle, vertical. Okay, so from the optical method, you get the horizontal distance. Lastly, we have electronic distance measurement. And electronic distance measurements, normally we put on the tenolite. The tenolite measure angles, and electronic distance measurements do aspective works. We call it horizontal distance measurement based on radio wave or based on the laser wave. And they integrate after this electronic distance measurement and tenolite to form, we call it total station. So by the end of that, we finish chapter 1 and chapter 2. All right. Okay, chapter 1 and chapter 2. Okay, so we finish for chapter 1 and chapter 2.